Hello all you scientists and mathematicians. Part 2 of Arithmetic Circuits today is intended to explain the logic behind arithmetic in base 2. So last time we just ran out of time for this. We didn't have enough time, we just got loads of history in. I wouldn't say it's a waste like this. I've written this PowerPoint very badly indeed, but no, it wasn't a waste at all. It was fun, you got to learn about lots of history. But we didn't really get any scientific education in, so let's not waste any more time and let's get on with this scientific education. Now, if you remember correctly, in the last part of this episode, I said that we're going to be talking about the structure of an arithmetic logic unit in this video. So the best way to do that is to actually choose what circuits we're going to use. We're actually going to be using a logic gate, and let's choose that now. So first of all, we're going to need to know how to add in binary. The best way to understand how to add two binary numbers is to start with adding in base 10. So let's ask, what is 0, 1, 0, 1 plus 0, 0, 1, 1? I can't add in base 2 yet, well, at least you can't. So what we would do is we would turn 0, 1, 0, 1 into a 5, and we would turn 0, 0, 1, 1 into a 3. This way, the calculation becomes 5 and 3, and the answer is 8. In binary, 8 is 1, 0, 0, 0, and therefore 0, 1, 0, 1 plus 0, 0, 1, 1 equals 1, 0, 0, 0. So what we did there to add the numbers is we converted the base 2 numbers into base 10 numbers, and we know how to add in base 10. So you can continue this and you can do things like 0, 0, 0, 1 plus 0, 0, 0, 1, and you get 0, 0, 1, 0. That is 1 plus 1 equals 2, so you can translate it into base 10 and then convert it back into base 2. So this works very easily in base 10. But how does it work in base 2? What if we didn't want to convert 0, 0, 0, 1 to 1, and we didn't want to convert 2 to 0, 0, 1, 0? What would we do then? So the logic that can be used to add in binary is 0 plus 0 equals 0, okay, that's fairly normal. 0 plus 1 is 1, well, that's also normal. 1 plus 0 is 1, that's fine as well. And the only really irregular one of these rules is 1 plus 1 equals 0. This isn't it to that last rule. I mean, 1 plus 1 equals 0 doesn't make a lot of sense by itself, but an extra 1 has to be added to the bit to the left. This can be applied to 0, 0, 0, 1 plus 0, 0, 0, 1 equals 0, 0, 1, 0, because the two ones in the column to the right cancel. Of course, 1 plus 1 equals 0, so the 1 and the other 1 in the ones column which you're adding together, they equal 0. 1 plus 1 equals 0. But of course that's not the end of the rule, we do need to add an extra 1 to the bit to the left. So we carry over a 1 generated when we added the two ones in the ones column, and we put that generated 1 in the twos column. Since there's no 1 in the twos column, there's nothing to cancel with it, and 0 plus 1 equals 1. So we get 0, 0, 1, 0. That's the logic. You might want to do a few more examples just to get it, but here's the idea. In base 10, if we do something like 5 plus 5, we get 1, 0, that is 10. How do we add this? Well, we've run out of room in the column all the way to the right. In the column all the way to the right, we can only have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can't put 10 as its individual symbol, we can only have 9. So what we do is we carry a 1 to the left and we start over. We start from 0. And then if we do 15 add 5, 15 add 5 is 20, 2, 0. Then again, we've added the two 5s, and we ended up with 0, and we need to carry a 1 to the left. That's the same idea in binary, except instead of having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so we have to add to get to 10 in order to carry the 1, we just have to add to 2 to be able to carry a 1, because we're in base 2. There are only two numbers that we can handle. We can handle a 0 and a 1 in binary. If you have two 1s in the same column, you can't have a 2, you can't have 0, 0, 0, 2, you have to have 0, 0, 1, 0. Which is why it carries. Bit confusing, but like I said, after a few examples, you should be fine with it. Okay, so now we've got that idea in your head. I mean, that's nice and all, but why don't we go and see this process in action with an actual adder, which I'll show you in Minecraft. Okay, so we're in Minecraft once again, and before you, you see an adder, a full working adder. And here we have the columns. We have the ones column, we have the twos column, the fours column, the eights column, etc, 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 all the way up to 128. So we can add numbers, okay? And first of all, actually, I'm going to talk about how an ALU adds numbers. Now, let's say we flick some levers on, some levers off, stuff like this, blah blah blah. So we've hit some levers up and down this machine, and let's see what we flicked. We flicked 2 1s, we flicked 1 2, we flicked 1 1 4, we flicked 1 8, we flicked let's make this interesting, and we flicked 2 16s. So here's how this all works. We have a 1 and we also have another 1. So what the adder is doing is it's adding these 2 1s, because of course there's only one column for the ones column. So there's only one column that will represent 1. So if you have 2 1s, that equals 2, and it'll shift over to the 2s column and represent it here. Although we have something turned on in the 2s column. So the carry from the 2 1s here going into the 2s column will also have the sum with this input to the 2s column. That'll make 4, because we have 2 2s and we need to carry again. So we carry into the 4s column. But there's already an input in the 4s column, so the carry from the 1s column that went to the 2s column, that now come to the 4s column, we have the sum with this 4. And therefore we generate another carry, since we have 4 and 4, which is 8, and we can't represent 8 with 2 4s, because we can't represent 8 with 1 4 because there's only one output. So we have to carry it again, and we carry it onto the 8s column. But look, there's already a 1 in an 8s column. So we need to add the 2 8s, and we carry again, and we carry into the 16s column. Now in this case, what we have is we have both 16s on. So what this will do is one of these will add to the generate. Okay, that makes it generate on its own, and it generates over to the next bit. However, because we also have one on in here, it should produce an output. Now here's what I mean by this. It's a bit strange when you have something like 1 plus 1 plus 1, because in real life 1 plus 1 plus 1 is 3, and then 3 in binary should be however many zeros, and then 1 1. 1 in the 2's column, 1 in the 1's column. So that's if we have 2 1s, 3 1s. So we did generate a generate. We generated a generate. We've generated the carry, which has gone onto the 2's, which is why the 2 should be on. But then a 1 will also be on because of the third input that is going into the 1's column. So we get 1 0. In this case, that isn't the case. We just added a load of numbers, and we should get that is actually correct. The logic's a bit confusing, but all you need to know is that that is correct. So now I'm just going to demonstrate, like I said, the 1 plus 1 plus 1, except instead of the 1 plus 1 plus 1, I'm going to do 2 plus 2 plus 2. So let's start off with 2 and 2. This should make 4. There you go, it's carried over. Instead of having 2 outputs in the 2, which isn't possible, we carried over to the 4, and now the 4th column is on. So that makes some sense. Although if we generate a carry by adding 2 1s, then we get another 2. So we have 3 2s. In this case it should be 6, which is correct. We have the 2's column on and the 4's column on. 2 and 4 make 6. Bit confusing, I know, but that's the idea behind an adder. Still, you need to try the algorithm out, you need to practice adding numbers in binary, and you should get the feel of this sooner or later. Okay, so we know the rule, we've seen the adder work, but we still need to know how to build it. What makes up that massive, immense circuitry that we looked at in Minecraft? Well, like I said earlier, we need to choose a logic gate. So what logic gate goes by the rule 0 plus 0 is 0, 0 plus 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 0? The answer is the XOR gate. This gate does all that but one thing. In fact, before we talk about that one thing, I want to remind you what an XOR gate does. You need to have one input on, or the other input on, to get an output. However, if you have both inputs on, there'll be no output, and if you don't enter anything at all, there still won't be any output. So there's one thing that the XOR gate doesn't do in our adder, and that is it can't add a 1 to the column to the left of it. So it can't generate a carry all by itself. So to solve this problem, the first thing we're going to do is we're going to make a three-way XOR gate. So like I said, 1 plus 1 plus 1 is 3, which is 1, 1. So the way we're going to do 1 plus 1 plus 1 is we need 3 inputs. Because we've got 3 inputs, we need to incorporate 3 inputs into our XOR gate to account for the carry that comes in. So we're going to add another XOR gate onto the end of the XOR gate, and we should theoretically be able to add another 1 into the XOR gate. However, there's also the problem where we need to generate a carry. If we have 1 plus 1, we can't represent it in the 1's column alone. So we do need to carry it to the 2's column to make 1 plus 1 equals 2. The way we generate a carry is with an AND gate, because we need both on to be able to generate and move to the bit to the left. When both inputs are on, we will generate to the bit to the left, and so we need to form an AND gate. The AND gate will determine whether an extra 1 has to be added or not. If the AND gate gives an output, it's directed to the third input of the XOR gate to the left. This acts as the addition of the extra 1, so when the carry goes into the third input, we add a 1 to the bit to the left. In my opinion, having something visual is the best way to understand this, so let's not go and build our own binary adder in Minecraft. Let's not go. Genuinely, I'm not going to go and build one because I have dragged on this video for an awfully long time. It's probably over the amount of time that I'm used to recording with. So we've spent a bit too much time on this video, and therefore, sadly, we won't get to build our own binary adder. But anyways, with our binary adder and our understanding of arithmetic in base 2, we're probably ready to start learning about memory and how to use memory to store values that the binary adder might want to add. We learnt that the XOR gate is the correct logic gate to use for building our own binary adder, and also that we need a three-way XOR gate. We proved the theory of adding in base 2 number system. So that's what we covered today. Next time we should be going over memory, and I hope you enjoyed, but more importantly, I hope you've learned.